Hello everyone, I'm Shahida Akalanka. This is the sixth video of in this tutorial and I'll explain adders, subtraction and multiplication in this video. First one is adder. What is adder? Adder is a digital circuit that performs addition of number. This is a binary codes addition. It's the summation get summation from that inputs and input circuit, and this is the we can use this mathematical operations for this circuit. This is a half adder and full adder. Adders has one is a first one half adder and second one is full adder. I'll further execute that half adder and show that this is the two inputs and this has two outputs, first input and second input. Then you can show table diagram. When we at the sum get the summation in inputs, and we have to know about binary addition. This first one is 0 plus 0 is 0, 0 plus 1 is equal to 1, 1 plus 0 equal to 1, and 1 plus 1 equal to 0, and that 1 carrying out. This is a carrying out area and the representing area. F is the representing normal value, C out is carrying out value. I'll show that in the from some tool. So those inputs are 0. I'll already created that, and input no any output. Then I input for one value. You can show F is 1. Now second input is 1, that also represents 1. Then I input those both two values for 1. Carrying out is 1 but not representing one value in this output, but out carrying out one value. And I'll show table diagram in this circuit. Go to analysis and table. A and B both inputs, F is output and C out means carrying out value. Carrying out value only, both A and B inputs must be a 1, then F0 and carrying out is 1. And next we have to go to the full adders. Why we are using full adders? Because we have, but we have not because now we have half adder. Why we are using full adders? Because if some values we cannot addition from the half adder, therefore we are using full adders. Those full adder and half adders are main different because at full adders have 3 inputs and 2 outputs, but half adder has 2 inputs and 2 outputs, and half adder more than speed half adder. Then this is the normal representation of the full adder, and it's interconnected this type of half adders from to the using half adders. Those one half adder summation get into the second half adder and it gets summation in output, and other carrying out value we put into OR gate, and second half adder carrying out value also get into OR gate, and it's called C out. This is the full adder interconnected concept. Then this is the full adder circuit and its truth table and table diagram, and A, B, C and C inputs are input. We using two NOR gates, 1, 2, 2 AND gates and 1 OR gates for this full adder. Then I show that one from simulator tool. Full adder I already created also full adder. This is a full adder, and when input A you can show S is 1, then input B is 1, S is also 1, then input A and B and now you can show carrying out value. Then I'll show C in is 1. What's value? If C in is 1, now you can show S value and out value. Then now you can show S value is 0, but C in is 0. Now you can show S is 1. This is the implementation in this circuit. I'll show you table diagram and analysis circuits, and I have one diagram and I close in analysis circuit. This is analysis circuit part, and I'll show that we move to the let's move to the report, and this is the table diagram. C in, C output, S out, and A and B. A and B is those two input. C in means C in and S out and carrying out value. Then this is the basic circuit, and we have to when we using for the addition from this circuit we have to multiple addition circuits. Then we have four inputs and two values. We can use two values for input: b1 a0 a1 a2 a3, b0 b1 b2 b3. I'll explain from the practical circuit, and those are the multiple values. I already created that one. Multiple addition and subtraction. Addition. This is the addition circuit. Addition circuit is A, B, C, D is one value, and B0, B1, B2, B3 is one value. This one value represents binary code representation. This is another value binary code representation. Then output is also binary code, and when we want to convert that to decimal code, and its represent is not S1, S2, S3. We into those first A section and B sections for binary two values, and you can show output also after addition. I'll show that you have to see in is 1, and you can show C in is 0. You cannot real value and 1 1 0. Now you can show and it's change. So if we use in C, it's also change. Then output is now it's 1. Now output carrying out 1. Show that this is the implementation in this circuit, and two by using two binary codes. One A section and B sections also binary codes. Then S section also binary output addition section from that two binary code. Then is the concept and subtraction. Let's move to the subtraction. What's subtraction? Subtraction also mathematical operation. That mathematical operations and mathematical calculations for using this we can use this circuits. It has a concept is a normal two's complement concept, and that concept using for this circuit. It also I'll already created that circuit, and then move to the logism tool. This is the uh, subtraction circuit. This subtraction circuits and adder circuits have only one different. It's using second value we are using no gates. Now input second value inputs are using no gate because of we using concept toast complement. Then we have to use this no gate for not sorry not gate for this. Then I'll implement that, execute, then see 1 0 you show 1 1 value 1 value. Now you can show I'll show that reset those everything and simulate simulate this one. Now you can show outputs and inputs in here. This is the two's complement concept in here. You can show change time to time these values, and sorry, I not implement, then simulate, and values are changing. Now you can show this concept 2, and it's a2 is 1, s2 also 1, not other change other value. Then I put a3 is 1, oh carrying out also 1. Then c in 1 is everyone is not a good value, that's a invalid situation. Then I c in is 0, we can got that 0 1. Then I input that, you can show is not this one. We have to input four values, and sorry, that in one you can show some values are wrong and some are okay. It's I simulate to run, reset that, and set simulate. Then now we can show this is the subtraction tool. This is also first binary codes, second also binary codes from decimal code, and this also binary codes after subtraction. This is the implementation of subtraction. Then move to the report tools. Okay again, and remember that VCC. We have to mention that VCC also must be a ground value. Also, when we get into VCC input is 1, you show a error message in our circuit. That's the situation we have to mention. Already mentioned. We have remember that it was must be a ground level. Multiplication also in here. We can use the multiplication two values using circuits. This is the concept, that circuit concept is this is, and using this type of multiplication two values and partial products and product, this is the product. And since always multiply the either 1 and 0, partial product are always either 0 0 0 0 or the multiple values. There are four partial products which are the added from the result. We can add from the partial using adders, and even through product has 8-bit and 4-bit adders. Then 2 by 2 multiplication. This is a 2 by 2 means we input only 2-bit multiplication 1 and 2-bit multiplication 2-bit values from for the multiplication 1 value, 2-bit multiplication for the 1 value. Those 2-bit multiplication, and after you can show the output is not only 2-bit, it's a 4-bit, and must be a 4-bit, and also that code that multiplication. I already clear the multiplication circuit. This is the multiplication circuit. Then I'll execute that. Run on means 1 and 0. 1 and 0 means 1 and 0 2. 0 1 1 0 1 and 2. Then I also 1 and 2. Now you can show 1 0 0 0. 2 by 2 means 1 2 3 4. Okay, this 1 and 1 using is a 4. 2 means 1 and 0 represent by decimal code is 2. This is also 2. 2 by 2 means 4. This is a 1 4 2 1. This is the 4 representation. 1 0 0 means in the binary code it's represented in the decimal form 10 value. It's represent the 4 value, 4 number, and I'll implement this area. First number is 1, and 1 means 2 and 3, and 3 divided by 3 multiplied by 2, its output is 6. This is a 4 value. 1 1 0 means 6, representing 6 in the decimal code. This is the multiplexer and multiplication circuit, and this I'll show how to execute that multiplication, and this is the basic multiplication concept using calculators and other things using this one. Okay, I think you get idea about multiplication, subtraction, and adder. Thank you.